turn it over to Alicia.
Thanks. I almost clicked the leave meeting button instead of accept the recording. All right, let me get my setup here. There we go. You can see it all right?
Yes.
Excellent. One thing that I would like to share before getting too far into it is I'm going to be coding in this development environment. It is play.kotlinline.org, and you can run Kotlin code here without having to do much setup. Of course, nothing is running here yet, but I will get into it later. They also have links in the top right for examples, hands-on learning, and koans. And I'll talk a little bit about koans later, but they are not for beginners to Kotlin. Well, you can do it, but it's a little frustrating. Okay, I'm Alicia. I'm a senior software engineer at Chariot Solutions, which is a consulting company based in Philadelphia, Pennsylvania. I'm going to talk about why Kotlin for Java developers. If you're a Java developer, why should you be interested in Kotlin? I'm first going to start off talking about what is Kotlin. I'll go over a comparison of Kotlin versus Java, highlight some of my favorite Kotlin features, and go over a short list of resources. You are welcome to ask questions during the presentation. I will check in with Becca to see if any questions are pending. Otherwise, I'll keep going. Okay, Kotlin. Kotlin is a programming language built by JetBrains. You may know JetBrains from using various IDEs like IntelliJ for Java. You can use IntelliJ with Kotlin, of course. JetBrains built both. Or PyCharm, RubyMine, WebStorm, a lot of different and great tools that JetBrains builds. And one of them is Kotlin. Kotlin is 10 years old compared to Java, Python, and JavaScript, which are about 30 years old. So it is a fairly young language in comparison to what we use day to day. Kotlin is a general purpose language that can run in many different environments. The JVM, Java Virtual Machine, is what I'll be talking about today. You can be a Java developer and use Kotlin in your code base right away if you want to. It all runs on the Java Virtual Machine. In addition to JVM Kotlin, there's Kotlin Native, which runs in its own VM, Kotlin Mobile Multi-Platform, where you write Kotlin and you can run it on iOS and Android. There's also Kotlin that transpiles into JavaScript, so you can do full stack development, mobile development, backend development, all development in Kotlin. Kotlin is the official language of Android. Years ago, all Android code was Java, and they switched over to Kotlin. Google says this is now the official language, but it does highlight there was a migration from Java to Kotlin, all in the JVM. Kotlin is also one of the languages used in Gradle, which is a build tool. If you're familiar with Java projects, you might already be using Gradle. Gradle supports Groovy and Kotlin. Groovy is another JVM language. But you can have your code base in Kotlin and your build scripts in Kotlin, and you can have your scripts in Kotlin, and it can just be great to have a single language in all your projects because it is so general purpose. And that finally, highlights how general purpose it is with scripting, backend, mobile, front end. It's really a great language. Now I'm going to get into Kotlin versus Java. Before I get too far into these points that I'll be bringing up, I want to highlight that just because I'm here talking about why Kotlin is a great language doesn't mean that Java is a worse language. Java and Kotlin are both really strong languages and are used very broadly. They're not going away. Neither of them are going away anytime soon. The great thing is that you can use Kotlin where you use Java, not necessarily the other way around, but it can be a useful tool if you're working on different projects or if you need to compare the two. I'll be going over 4 points: programming paradigm, ease of use, framework and library compatibility, as well as learning and support. When we talk about programming paradigms, we mean how do you write your code and how do you architect your code? This is how you might plan out what are your packages, what classes do you have, where do responsibilities go. For Java, historically and traditionally, it is object-oriented programming. Java developers have a well-known set of patterns of how you design object-oriented programs and architecture. It's a slightly different paradigm than what we might see in modern languages. And when I say modern languages, I mean the current form of something like JavaScript, Python, or Swift, where those paradigms move more towards reactive programming or functional programming. That isn't to say Java is only object-oriented. It is constantly being updated to incorporate those paradigms, but that modernization can be a little bit clunky. And I'll highlight some of that clunkiness a little later on in the presentation. So in some ways, traditional Java is different from what you might see in JavaScript, Python, and Swift, which can be a problem if you have a multi-language code base. Or if you are building backend in Java and your front end is in JavaScript, there can be some gotchas, and it can be hard to ramp up to that. Kotlin, on the other hand, once again, it's multi-purpose. It supports functional object-oriented scripting as well, as I mentioned in tools like Gradle and just traditional Java programming. So it's much more flexible. But, you know, programming languages, you can do everything in either. Oh, I went too far. Ease of use. You have the programming paradigm about how you should architect your code. And then there's ease of use. How do you write good code? Java idiomatic code, and when I say idiomatic, it's kind of like the dialect, the coding dialect you have. Idiomatic code means code that is written in the way Java should be written, usually by a style guide or other community guidance. Java idiomatic code can be more readable. It's usually more explicit. You have if statements, and I'll show you a Kotlin alternative to if statements. I'll highlight how the Kotlin code is really concise, but it's a bit of a mystery how it works until you actually learn Kotlin really well. Whereas if you're coming into Java from any other language, it can be a little more readable. Even though it's more explicit code, it's easier to write code with bugs. And I'll point out a couple of bugs that you might encounter as a Java developer versus a Kotlin developer. And again, a lot of this highlights, if you're already a Java developer, you're fine. But if you're someone who's coming in from Python, trying to build a backend, Java can result in bugs, and I've seen this happen, and I'll point those out as I mentioned. Java code is more explicit, it's not as concise, and we talk about it having a lot of boilerplate. There's so much boilerplate, there's a lot of tools and libraries to get rid of it. When we say boilerplate, we mean all that code that you have to write doesn't really do much just to set it up. Traditionally, an example is getters and setters. So you have a Java class, you have name, address, country, and then you have to do get country, set country, those getters and setters that we talk about. Nowadays, most people use Lombok, Project Lombok, to build that boilerplate code for you because it's so annoying to write it. So Java can be more readable or more approachable. It's easier to write bugs in Java code accidentally. And finally, you need to be aware of the versions. Java 7 to Java 8 was a massive change. Java 8 to Java 9 had a lot of great improvements. And each version of Java that we add almost adds new paradigms. Java 7 to Java 8 added streaming APIs, which are really common in a lot of the current programming languages we use, but it initially was really clunky in Java and kind of painful to use. But it's been improving all the time. But it does mean you have to know what's in Java 9 but not in Java 11. Well, what's in Java 11 but not in Java 9. And you have to be a little more current with the language. Kotlin is younger, and so it doesn't have so many language versions that might confuse you there. So on the Kotlin side, I just went over the Java, just like I mentioned, it is easier to write safe code by default. The code is more concise, but it could have a learning curve. In Java, when you write something in 5 lines, that can be 1 line in Kotlin. Well, those 5 lines did have information, and it was very useful. And now suddenly you have this 1 line and you're trying to figure out what all those question marks mean. And so the code can be a little more implicit. Concise code can be really nice to look at once you get the hang of it, but you can be scratching your head about where a bug might be or where to put a breakpoint when everything's 1 line. Next is frameworks, libraries, and tools. When you pick a language to use, you don't want to have to rewrite everything from scratch. So you look at what can I build with that language? What's already been built with that language? And how easy is it to build with that language? So you look at frameworks, libraries, and tools that will help you not rewrite everything and reinvent the wheel. Java has so many libraries and frameworks available. It has a whole history of being a core programming language. Now it's primarily backend, but you were building desktop applications, web applications, everything was being built in Java. So there's a huge amount of support. It has drifted more towards backend, which is where we get libraries like Spring Boot. And that has amazing support for building quick backends, and it's all in Java. And Java itself is still first class for many products and companies. So you're not going to suddenly see Java jobs disappearing in favor of Kotlin. It has really deep roots in technology. However, with Kotlin, you can build on those deep roots by using the same frameworks, libraries, and tools. Now, you can't just go to a company that codes in Java and say, I'll just do this in Kotlin. Culture changes are a little bit different, but all Kotlin JVM, which we're talking Kotlin JVM, you can use all the Java libraries too, and they are mostly compatible. And this is where this mostly part comes in. Most of the time, you can write your Kotlin code with your Java libraries and everything works great. But every once in a while, there's going to be a bug or some compile error that's really mysterious, and you're trying to understand what happened. Why can't I use Kotlin here? And that can be a huge hurdle to jump because Kotlin is still in early adoption. There's one particular bug in Spring Framework where when you're trying to use the database libraries, you can't really use Kotlin the way you would think you can use Kotlin. As time goes on, though, these frameworks are considering Kotlin and they're expanding their support to include Kotlin. The last thing that's a bit of a downside of Kotlin, I mentioned it's general purpose. You've got mobile, you've got web, you've got native, you've got JVM, and you have to choose between platforms. You can probably copy paste code, but it may not be available in the other runtime environment, or maybe the API is slightly different. So while Java, you had to be aware of versions, with Kotlin, you have to be aware of your platforms. It's a little easier to change Java versions than it is to change Kotlin platforms. Last thing is learning and support. It's really hard to just code in a vacuum with no internet. You definitely need help. And online, we tend to search and look for resources, tutorials, answers to questions. And so that's another key factor to consider when you're picking a programming language or when you're comparing them. How easy is it to get help and find answers? Java, again, really long history. You're going to find solutions to almost every day-to-day problem you'll face in Java. You'll have fixes in a whole bunch of different versions of the language, but something is going to work and it's going to be out there. There are a lot of Java groups. So there's tons of Java podcasts. Oracle has groups. There's Java developer groups. There's actually a big community of developers because it's such an old language. It is still alive and active and being updated constantly. There's new and exciting features coming out in every Java release. But there's a ton of stuff there. And when you are using Java with AWS or with Kafka or with Spring Boot, all the examples are in Java. It makes your life really easy. Kotlin, on the other hand, is really strong in Android, and there's tons of Android examples. So when you Google, how do I do this in Kotlin, you have to be careful not to pick the Android example because Android has a different architecture, and you may not want to use your Android code in a different application. It is, as I mentioned, gaining adoption, but you're still going to have to look at this documentation for Kafka or AWS and think, how do I convert that into Kotlin? And you can actually write Java-like code in Kotlin, but then you're not writing idiomatic Kotlin code, and then it goes back to ease of use and how do I write Kotlin code in a Kotlin way. And just a comment on open source, both of them are open source. Kotlin is fully open source. So everything Kotlin is, was, and ever will be, hopefully, is open source, and you can go and contribute to it right now. Java is still driven by Oracle, and that's an enterprise edition. So there's an enterprise Java and an open source Java. You may be familiar with adopt open JDK. Now Kotlin still has to run on Java. So you're really running on the open source JVM of Java. So it's a little bit misleading to separate them. but Java can be open source as well. But just to keep in mind, there are 2 versions, but there's only one open source Kotlin, which is multi-platform. So you're going to see open source for all the different platforms. All right, that's it for the comparisons, slightly slanted towards Kotlin because this is a presentation about why you might consider Kotlin. But I use Java day to day, and it is fun to work on Kotlin backend, but I mostly get Java backend work these days. I'm going to go through some Kotlin features that I like. I can't teach you the entire Kotlin programming language, but I'd like to highlight some features that are really nice in Kotlin compared to Java, and things that I wish Java would improve, which they are. Every time I see a new release of the Java language, it looks more and more like Kotlin. For this, I am going to go into this coding editor that I shared at play.kotlinlang.org. I'm actually going to share it one more time because I know that Zoom does not give you a history of chat. All right. This editor, you can write some code. You can hit the play button and it will play. Of course, nothing is happening in this code, so that doesn't really do anything exciting. I will start off having it do something. So print hello, feature. Okay, sorry, comments about Zoom not sharing history. Okay, so you can add a print line. If you're familiar with Java, it's system.out.println, but hey, we don't need the system.out anymore. And so we can print hello. Let's start off with function definitions. And I'm going to write these function definitions because I'll be using them. So I'm not necessarily going to go over only the features that I listed in my slides, but I'll be going through a bunch. And unfortunately, I may have to code fast. Apologies if it's hard to code along. All right, functions start off with fun. Kotlin is fun, easy to remember. This is similar to function in JavaScript or def in Python. Notice we don't have public, static, void, all those things. It's really concise. So I want a function that says hello. So I'm going to write this out in more expanded Java format. So I have my function name. There's a parameter, space for parameters there, which I'll add in a minute. And it's going to return a string. You can specify the return type by a colon, space, and then a string, which is the type. Then we can have an open brace and close brace, just like you might be familiar with if you're using Java. And then we can return hello. Pretty easy. So we can then call our method hello here, and it will print out hello, hopefully. So we get hello. Great. So that's how you can do a function definition. But in Kotlin, I can be even more concise. I'm just returning this string type. Let's get rid of all of these extra characters that I don't think I need. So now I have this function that is much more concise, and it returns the exact same thing. So this is infix function definition, and it can be really concise. How many Java functions have you written that are one line and you're like, this is 3 extra characters or 3 lines I really don't need? And Kotlin can make that really concise. All right, let's talk about parameters. And you notice that when I defined my return type, I had it as a colon string, and that's kind of how we do parameters as well. So I can do name string, and I'm going to change this to return hello $name. And I'm going to do a little bit more with this in a little bit, so I will expand this out. And now I can do hello Alicia, and it should say hello to me. Oh no, it is an unresolved reference. I misspelled return. All right, so now that works. I've got my parameter coming in. Now we can get into one of my favorite features of Kotlin, which is nullable types. Okay, so this is a string. And if you're familiar with Java, you can just pass in null here, and that's no problem. But you can't do that in Kotlin. If I try to run this, it's a compile time error that says you can't assign null to a non-null type. If I want to make something nullable, I put a question mark at the end of it. Any type followed by a question mark means it could be here or it might be null. And this allows me to assign null to it or pass in null. And it says hello null. This means that at compile time, you know if this is a valid assignment or if this is null or not. So at runtime, you don't have to do those if equals null checks that you have to do all the time in Java. So let me take a second to, oh, you know what, I'll switch my slides for a sec. I've got my function declaration, we have nullable types. And just as I mentioned, if you have a question mark, it means you can return null. So if I'm writing a breadth first search function for whatever reason, maybe I'm in a coding interview, and I'm not sure if I'll find my node, I can return null in Kotlin. And whoever's calling this function knows this might be null, it might not exist. However, if I change my function signature to be no question mark, so non-nullable, this will be a compile time error. You can't build your code, you can't ship it to production. Java does have a feature that works like this, and it's called an optional. When you have your breadth first search in Java, you might say, I'll use the optional to describe something may or may not be here. So optional.empty means nothing was found. Great, so why don't we just keep using Java? It has optionals, no problem. The problem here is that you can still return null. You can write your function and say, all right, it returns empty when nothing's there, and it returns an optional of node when it is there, but someone can still return null. You can still build it. You can still deploy it to production, and then you're going to get a runtime null pointer exception when this code executes unexpectedly. So you're going to start writing bugs in production accidentally. And this is what I meant where Kotlin can help you write safer code. All right, so these are nullable types, but I have this hello null here, and I actually don't want to print hello null. I'd like to just have hello. So if we want to use this, we can say if name is equal to null, we can return hello, else. I always have issues with these autocomplete. Sometimes I like them, sometimes I don't. Okay, so we can write this change so that when this is null, it just returns hello. But this is a kind of Java-y explicit way of writing this. We can write this in a more concise way. All right, so we're actually going to maximum concise this and shrink it. And we can do something called null coalescing. Let hello $name. It is not ternary. And we do hello. So here, and this screen is making my life a little difficult. So here we're going to get the same result. We get hello. And if I pass in my name, we get hello name. This is called null coalescing. And you might see this in other languages where this is saying, if this is null, so are you null? Like I like the question mark there because you're kind of not sure. It will execute this let block. So if this is not null, execute this let block. And there's a whole bunch of stuff about let blocks and you're like, where's your return statement? It's returning the string. We can see that, but it's got more to it. And this is where I'm talking about, if you're looking at idiomatic Kotlin code, you're like, do I know what that's doing? And it can be a little tricky to learn. And then we have our Elvis operator. Elvis is a famous musician in the United States who had wavy hair like this, and he had 2 eyes, and that is what makes his hair in his eyes. Okay, so this is, if you're not null, please execute this code block. Otherwise, do this. And it is similar to a ternary operator, but it is specifically for handling these null types. There's a whole bunch of other stuff you can do with them. And notice that this is my one-liner, and there are no semicolons. And you're like, wow, this is one line. Now, we do get into the problem where, is this really readable code? You can change your style depending on what your team likes or what you would like to do in your code base. This is a more expanded way to do it that can make it a little easier to understand. A lot of people are okay with having it on one line as long as there's only one statement in the let block. This is also really similar to Swift if you're familiar with Swift. Okay, so now we have our nullable types and our null coalescing, and it's really nice because we can easily change our code behavior and we can know for sure if something's null or something's not null. The next thing I'm going to go into and I've got my examples in my slides, I will share my slides, is list immutability. I'm not going to go into this in the editor because I need to have both Java and Kotlin. When you create a list in Kotlin, by default, unless you specify, it's immutable. Immutable means if you give somebody this list, they can't add or remove from it. When you talk about Java, we have a lot of pass by reference. It means in Java, you give a function a reference, and it means they can edit that object because they have the reference to that object. This means that you might call a function and say, this is my list of cities, and it's of size 10. And then next thing you look at the list, it has 15 cities. What happened? Where did those come from? And that's because you passed a mutable list in. And this is where it can be safer programming if you are programming in Kotlin and you use the defaults. When I look at this val my list of, this is the default list constructor if you want to directly make a list. And it means you can't change. So here I've got this red add. It is a, again, compile time error if you try to do this. You can't build your code. You can't deploy it to production. You're just not allowed to add anything to an immutable list. Or you can say, okay, I really do want it mutable. Please let someone change this, and I can make it a mutable list. Let's look at Java. If you create your default linked list or array list or whichever list you would like with the new keyword, it's going to be mutable by default, which means if you pass it to someone, they can add or remove items. Maybe you get an index out of bounds exception, or you run out of memory because there's too much stuff in it. Now you have to be really careful to tell people, please don't modify my list. And that's where the collections API comes in, where you can say collections unmodifiable list, my list. But the default, if you just look online and you want to create a list, the default for Kotlin is safer, and the default for Java is a little scarier. Now, Java 9 has released a list API, streams API, or collections API, streams API improvements, either 9 or another version. Me trying to keep track of all the versions, but you have this list of, which looks suspiciously like Kotlin. Every release looks a little bit more like Kotlin, and this is creating an immutable list. Okay, so I can add to my mutable list, and I can also add to these two. It's not a compile time error. I can still ship this code. But if I try to run these last two, which the IntelliJ IDE is telling me something's wrong here, it will throw a runtime unsupported operation exception. So again, Java, you're probably going to get unexpected runtime exceptions because these do not enforce anything compile time, but Kotlin does. So it can make it much easier not to have surprise bugs in your production code, and you're like, why is this method changing my list? All right, I'm going to move into collections and streams. Okay, another detour to get everything set up. I'm going to talk about classes. So I'm going to create a data class called friend. Friend is going to have a name, a city, a state. We're going to zoom out a little bit here. And maybe they have a pet. I'm not sure. Okay, so here's how I can declare a class that has 4 properties: name, city, state, and pet. Maybe they have a pet, maybe they don't, could be nullable. But they all have these properties, and that's it. That entire line, I now have a class that I can create instances of, and I can use these properties of. That's it, one line, I've got a class. Think about Java, where you have to write your properties and getters and setters, and you have to bring in Lombok, and it can be a real mess, but super easy. To be fair to Java, Java 16 or 15 introduced record classes, which look exactly like data classes, except instead of data, you have record. So as time goes on, Java's looking more like Kotlin. They're addressing these issues where it can be clunky. But for now, I think the most current version of Java is 11, and it doesn't really have these widely used. But Java 17 is coming out in September. We're going to start using record classes. So a lot of this comparison between Java and Kotlin is going to be out of date pretty soon. Okay, so let's create a friend. We're going to have friend. I think I can keep spelling my name. I'm in Philadelphia, PA, and I have a cat named Europa. There we go. That's my constructor. Notice the absence of new keyword, saving tons of characters when you're writing Kotlin instead of Java. And I can do print line. Well, let's do it this way. Alicia.name lives in Alicia.city. And I'm just going to comment this out because I don't want all these print statements. Okay, now it says Alicia lives in Philadelphia. Really easy. I just do dot notation to access my properties. I've got my string templatization, which is another amazing feature. You know, if you go from JavaScript to Java and you're like, am I really doing string concatenation for everything? Super nice. Great. But I actually don't want to have to do this explicitly every time. I'd like to make this a method. But let's pretend that this friend class is in a library and I can't rewrite that library, but I just need to add this one function. By the way, the val keyword, let's do this for a second. Val name equals Alicia and our other name is equal to Meg. All right, so val and var are both ways that you can declare a variable, and the type is inferred. If I would like to be explicit about the type, I can make these typed just like you would parameters or return types. Val means it is unmodifiable. So if I tried to do name equals Becca, this would be an error. So if I try to run this, it's a compile time error. This is a constant final. If you're familiar with Java, think final. So you can't change it, but I can change other name. So I can make that Becca and it still prints out the same thing. So that's the difference between val and var. Okay, so now you're like, great. Now Kotlin looks more like JavaScript. However, Java 10 introduced the var keyword, so you can declare Java variables with var as well. Again, the little steps towards making those two languages the same. All right, I have this friend and it's in another library and I just want to add this function to print the name in the city. So we can create that super easily. So we have fun friend name city equals, and we're going to do $name lives in $city. I've got my extremely concise declaration here, and I can just do Alicia dot name city. And I will explain a little bit more about what's going on here. And this prints the exact same thing. So what's going on here? I have this class, it's in another library. I just want to add a new function to it. Java, maybe I have to have a mapper class or a utility class. Maybe I wrap this friend object into my local friend object to try to add a method to it. It becomes hard to I just want one method on this other class. So you can use an extension function. You can add a method to any class that you want to, and it's super easy. You just extend it. You don't need to go to all the effort to have all these different methods associated with different contexts. So I like that. Okay, now let's get into the actual collections. I need a list of friends, and it will be a list of. And also note there's like no semicolons anywhere here. You can put semicolons. If you miss semicolons, you can have semicolons. Some of the IDEs will get mad at you about it, but you can also use semicolons to separate statements on the same line, just like you could do with JavaScript. Not sure if you're writing Kotlin code like that, you may want to think about a little more about what you're doing there. But I'm going to make a list of friends. So we're going to copy this. And notice I'm using list of, so this will be immutable. So we will have Sarah in Seattle, Washington, and she doesn't have a pet. It's very sad. But we will have Hanako in New York, and she will have a dog named Toby. And she will also have a capitalized name. Now this is gonna be an error because I am missing the pet parameter here. So if I run it, it'll give me an error, hey, you have no value for pet. What I can do is I can pass in a default value. So if you don't have the pet provided, just use null. This means that with both parameterized constructors and optional constructor values, you only need one constructor. If you're trying to do this in Java, you need a different constructor for every combination of parameters, and it has to be ordered. If I wanted to order these differently, I can use this parameterization and put them in a different order. Think more like Python. So these, very nice quality of life things that they've put in this language. Okay, so we have friends, and I can print my list of friends. And I'm going to get rid of these print lines because they're going to get kind of messy if I keep them up. And so I have this list of friends. So it prints out the friend object that I created. But I don't really want a list. I actually want a map from the friend name to the friend object, because I'm going to be looking up by name and I don't want to have to do a search through a list. So how am I going to do that? So I have friend name map. And in Java, if you're trying to turn a list into a map, you're going through a for each and then adding a key and a value after you've constructed a map. And it can be just really annoying to get that working. But let's look at what Kotlin does. Associate by it.name. If I do this, I create that map of name to friend. Is that right? So now I end up with a map that goes from Alicia to the Alicia friend object for Sarah and Hanako as well. This just, if you've had to do this in Java, if you've had to make a map out of a list, it's just amazing how great this is, where I just do associate by, and magically it gets me. Now, IT, that just came out of nowhere. And more on the readability of Kotlin. What's happening here is effectively the Lambda style notation. This is a block that takes in a variable called IT, which is a friend coming from the friend array, and you are calling it.name. You can change it to say friend is friend.name, and that's a little more readable. So you have to choose. Do I want more readable code, or do I want it to be really concise? All right. However, you have a whole collection of associate. So you have associate by itself, and you can do it.name to it.city. And you can run this, and you just get name to city. Like, it's so much easier to turn lists into maps. And this is something that greatly improves my quality of life. There's associate to, associate with, associate by, and then just associate. And you can also associate it with things that aren't in the list. You can do this particular block doesn't have to be one line. You can have more stuff in there. So I'll show a small example of that in a sec. All right, so I've got my map. Associate is great. The next thing I want to talk about is sorting. If you have tried sorting in Java, you probably know about comparators or the comparable interface, and you'll get interview questions that are like, sort this, and you're like, does compare to return 0, 1, or -1? And you're just trying to figure that out for a while. And this can be much easier with Kotlin. All right, so we're going to sort these. So we take our val sorted friends by name. Kotlin can still use the Java naming style, which is very verbose, but because it's also popular in functional programming applications, you may also consider having things like S. So whatever works for you. We'll take friends, and we can do sorted by descending. Wonderful. It made my life easier. Sorted by descending it.name. And we can print this out, sorted friends by name. And we get the friends sorted by name. Now, it's a little hard to see this, so what I want to do is make it a little more concise, but that's it. All you needed to do to sort it descending by name, that's it. It's a method directly on any collection. again, super nice. If you're familiar with Java, you're here doing .stream, .map, .sort, and then you have your comparator here. It's a real mess. It's super clean. Okay, well, what I'd like to do instead, I don't really want the full friend. I would like to map it to the name.
Alicia, what is it referencing again?
IT IT means the thing that you just passed in. Okay, so we have this friends associate. Let me actually do this map here for a sec. IT.name. Okay, so I'll remove this. So if I print this out, it's not actually sorted. So it says Alicia, Sarah, Hanako. And I actually just extracted the names and put them in their own list. So what does this look like? This would be something like for friend IT in friends. And then we might have another list, writing this sort of Java-y names. And that's not correct Java, but names dot add IT. So this is kind of what it's doing. When I do friends.map it.name, this IT refers to the default variable being passed into this block. So it looks like IT goes to it.name if you're familiar with lambda notation in Java. Alternatively, you can change this to be a different name. So you can do friend goes to friend.name. And it's up to you and your team whether you want readable code or concise code. And you may think that it sounds obvious you want readable code, but everyone has their own style. So here you would be instead making a separate list of names. You do a for loop over the friends, each friend in your list of friends, and then you add the name it.name to that list of friends. And I call it IT. I think of it as like iterator, but it's not always an iterator. So maybe it's it, but sometimes it can be funny to think about associate its name to its city. Is it readable? Is it confusing? You know, how do you code and how do you prefer to code is kind of a style thing. Okay, so we've got map. Map is really similar to what you have in Java streams. It's basically the same thing. Different style of notation though. So this is just names at this point. So sorting can be really easy and save me a lot of time, save me a lot of API mixing around, and it just does it for me. The last thing I want to talk about is, for my collections, is sequences. If you are familiar with functional programming, you may be familiar with sequences versus collections. If you are familiar with Python, think about a generator. And I don't really know the JavaScript equivalent. There's only so many languages I can be proficient in at the moment. But the idea of a sequence is it's a lazy list, and that's another way you can call it. It means that you don't evaluate all the items in your list until you need them, and I'm going to show an example. So here I have my names, so friend names, and I have a map that goes from friend to friend.name. And I'm going to change this up a little bit. So there's 2 lines in here, and one of them will print hello. So every time we map a friend to their name, we're going to print hello. Let me just, it's going to bug me if I don't do it that way. So let's run that. We're going to hello, hello, hello. Of course, we ran this 3 times. And I will do a print line, names.first. So give me the first one. So we're going to see hello printed 3 times and then the first name. But what if I have like 1,000 of these and I'm not really sure if I'm going to need all 1,000 of them? What if I'm probably going to need the first 10 and maybe the first 20 later, but I'm going to be looking at the 1,000 over a month or over a couple hours, maybe a month is too long. So I don't actually want to evaluate this every single time. So that's where we get into sequences, lazy lists, or generators. Names, well, we'll call this lazy names. And we can do as sequence at the end of any iterable collection in Kotlin. You just write .as sequence and it becomes a sequence. How does that change the behavior? I can do the exact same thing here and do a map. And I'll do the same friend goes to friend.name. And with these different blocks, there's rules around the blocks. How is it that this is returning, but this one isn't? By default, the last statement in the block is the return value. And this is what I mean about there's a learning curve to knowing what's going on in Kotlin. All right, so we will print line there. So this lazy names, it looks really similar to this. The only difference is I'm calling as sequence first. And I will do the exact same thing here and do print line lazy names dot first. I'm going to run this, and you'll notice that hello, hello, hello runs, then Alicia. This was the regular map, but there runs once, and then Alicia. This ran a single time because I only got a single item. When you use a sequence, it only evaluates the map function for the collection when you get the item. So like I said, you might be processing one item per minute. So do you really need to go through all 1,000 of them when you create your list? So sequences can be really great. Of course, you can do sequences in Java as well. It's just really tricky because it's not built into the API as easily. So let's try this again. Print line lazy names dot find first. Is it going to give me trouble here? And let's see if I can remember the syntax. IT is equal to Sarah. Unresolved reference. Yeah, I can't remember the exact API for this one, but the idea is that if I try to get the next one, it will print out the next one. So that's the nice feature there about sequences. If you get into functional programming, again, sequences and lazy lists and generators are really common. And this is where the paradigm comes in. Kotlin is written to have optimization for functional programming paradigms. We have these nullable types, which can be considered a maybe monad for functional programming. We have sequences that function as lazy lists. If you're not familiar with functional programming, it also has a massive learning curve, so don't worry too much about it. Okay, I do also want to point out that with every release of Java, there's more support for collections and streams, and the API is getting less and less clunky. In Java 8, every time you wanted to process a list, you had to have .stream. Now, as of Java 9, I think it's improved, or Java 11, I think it was actually Java 10. Again, can't keep my version straight, but there have been improvements over time. So here are my slides. I based my slides off of one of the exercises. Yeah, first or null is another example. There's a ton of stuff that you can do with Kotlin and first and predicates and any and all that kind of stuff. So I based this off of the Kotlin koan for collections. Now let's briefly look at koans. Koans are an exercise to learn Kotlin if you already know Java. And they are little puzzles. So this is the collections one. There's little puzzles, you can see I did these, that say, sort by descending. And this is the solution I wrote. And it helps you go through the examples. Kotlin koans are sort of more frustrating because they say, you're a Java developer, you probably know what you're doing. Figure out how to do this. The descriptions aren't super helpful. If you're more interested in learning from the beginning, the examples here are better. So I did pull these pieces of code from the koan, and so I'll share the slides later, so that's where it's coming from. I discussed associate by, sort by descending, and sequence. Okay, the last big thing, or the thing that everyone talks about with Kotlin versus Java, is coroutines. In order to explain coroutines and why they're different from Java and why they can be better than Java multi-threading, I'll need to explain both. So if you don't get it right away, it does take a while for it to all make sense. There's a lot of concepts wrapped up into this comparison. Let's talk about Java parallel programming. So there's a difference between asynchronous and parallel programming. Java style is parallel programming, where you create a thread. And when you create a thread, you ask the operating system for a chunk of memory of RAM, and you use that as your execution environment. Java will define a task, give that task to that thread, and that thread will keep running until that task is done. And when it's done, it will release the memory it requested from the operating system. This means that you can't have an infinite number of threads. You are limited by memory and CPU on your machine. So if you have experience building production applications in Java, you start saying, okay, how many threads do I need? How many CPUs do I have? And what's the RAM? You're very coupled to the hardware. And speaking of running these tasks on threads, it will run until it's done, and it will just ignore everyone else. It will run uninterrupted. It will stop for no one unless you forcibly terminate the process. With the caveat that you can use the yield keyword in Java to indicate that the code can wait for somebody else to execute, and then it will resume. Special note that there's a project called Project Loom that will be coming out with Java 17 that implements virtual threads, which means you can have as many threads as you want and you don't need to worry about your hardware anymore. So again, this problem with Java where threads are heavyweight and you have to know about the operating system is kind of going away. So becoming a stronger competitor with Kotlin Coroutines, but they're not the same thing. Okay, so you have Java, I give a task to a thread, which I've allocated resources for, it runs, it ends. Coroutines. You can create a section of code or a task that can be run anywhere, interrupted at any time, picked up, put down, and placed on any available thread. This means that if you only have one thread running, you can still have a ton of asynchronous coroutines queued up, and they'll just keep alternating and figure out who needs to go first and priorities. But you don't need a thread for each task. And it scales to different architectures. If you can only support one thread in your application and 10 threads in another environment, they scale. Coroutines will run on one thread, 10 threads, 100 threads, whatever works. And you can dynamically change it as well. They can be interrupted anywhere, like I mentioned, and you specify it with async keywords and the suspend keyword on the function. So you do suspend fun, which there's, of course, jokes about how coroutines are not fun. But anyway, so you can also specify atomic blocks, but I'll just leave coroutines at that because it can be kind of difficult to even absorb this much. So parallel programming are two tasks running in parallel on dedicated resources. Asynchronous programming means the code that you're writing in your method can run at any time, but it may not be running in parallel. And the great thing about Kotlin coroutines, it can be architecture, physical machine independent, whereas Java, you really have to pay attention to it. And you have to go out of your way to make it share and play nicely. Java, you have to say, play nice with this code, where Kotlin doesn't have to impact any of your other coroutines. So to wrap this up, I have a metaphor that hopefully will help you relate a little better. So I want to read a book, and I'm going to read a book on a Java thread. I take a specific copy of the book, I sit down, I read it cover to cover, and then I put the book away. That is how you do traditional parallel programming in Java. If you want to use a yield keyword in Java, so you're trying to make it a little more reasonable, you can put a yield keyword at the end of every chapter. So you sit down with your specific copy of your book, you read to the end of the chapter, check if you need to do something like eat, and then you resume and keep reading, but you keep holding on to that book. You don't put that book away. Kotlin, you want to read a book, you can pick up the book, put it down, pick up a second copy of the book, get the book later, borrow your friend's book, get another copy of the book at the library, read whatever copy is available at any time, and you don't have to stick to one copy, and you don't have to read any portions altogether. So it's like a completely different way of parallelizing your code. Now, that being said, you're like, I don't really want to stop my reading in the middle of a sentence. And that copy is stained, and I'd rather read the unstained copy. So there are pros and cons to each approach, but one of them completely decouples you from hardware and the other doesn't. They each have their purpose. So hopefully that clears up a little bit about coroutines and why people are talking about them so much. That's all I have for the presentation. And I have some resources I would like to highlight. There's Kotlin by Example, which was the examples website I shared here. I'll copy some of these into chat. There's the Kotlin koans I mentioned that are primarily focused on helping Java developers learn a bit about Kotlin. There's this really awesome coroutines tutorial that goes over what is single-threaded programming, parallel programming, callbacks, and coroutines, and it just explains it with wonderful diagrams. Spring Boot in Kotlin, if you are a Java backend developer and you want to try using Kotlin, Spring Boot does have a tutorial for it. You can contribute to Kotlin because it is open source. And finally, there is a website where I've gotten a ton of Kotlin and Java books. It is called Humble Bundle. It is a website that's primarily for buying video games, but they do have book bundles. And sometimes they'll have a Java book bundle where they'll have Head First Java, Head First Kotlin, 97 things a Java programmer should know. And I've gotten a ton of books there, and it is budget books. So $25 will get you 20 books. And it's a great way to pick up languages. They also have, Python and mobile and all that stuff. But it's something worth sharing if you want to learn more, but maybe you're into sitting down with a book with taking breaks, not sitting down reading it cover to cover, versus tutorials online. All right, that's that. Any questions?
I have a question, Alicia. Do you have a recommendation? So I'm coming from a JavaScript background and I'm starting to learn Kotlin. Do you have a recommendation of a starter beginner project where I can start to kind of apply Kotlin?
I think with Kotlin, if you're coming from JavaScript and you're doing full stack development,
it's mainly back end, but I would like to incorporate a little bit of front end, but mainly back end.
I think starting with Spring Boot and Kotlin, Spring Boot is kind of heavyweight, but it is one of the most popular JVM backend applications. And so you'll be able to create a simple application that has a REST API so you can interact with the database and get data back. And it's a really nice way to get started with Kotlin backend. So I'll share that link here. And then whatever you learn in this tutorial does apply to Java. But it can be a little nicer to learn it from the Kotlin side, especially if you're coming from a language like JavaScript. One of the things that I've seen happen where JavaScript developers go into Java is the equals operator. Equals does not work in Java like it does in every other language. So that gets people a little bit. Equals in Java means object reference. Does the pointer match? So this pointer is pointing to address 7 in memory. Is this pointer also pointing to address 7 in memory? It's not at all whether they're equal or not. It can be very confusing.
Okay, thank you.
No problem. Hope that helps. All set then, Becca?
Yeah, thank you so much for giving this talk today, Alicia. This is really awesome.
Yeah, no problem. Let me, I'm just going to finish sharing all these links, and then I'll put the slides in the chat as well. It's kind of challenging to copy links from slides and put them into Zoom.